Chapter 6 today, woohoo, and today we're going to do graphing systems of equations, and we're going to solve systems of linear equations by graphing. Sounds scary, shouldn't be too bad because you know how to do most of what we're going to be doing. It's just kind of putting some things together that we've never really connected before. So, a system of equations is a set of equations that share the same variables. Most often the variables that we're going to see, at least for now, are x and y. Okay, we understand those. You have an x coordinate, y coordinate, you graph those on the coordinate plane. We know all the forms of equations, like standard form of an equation, ax plus by equals c, and we know slope-intercept form, y equals mx plus b, and we know point-slope form, and that kind of stuff. And those all use the x and the y, right? And you understand how to graph those equations because we've been doing that since pre-algebra. So a system of equations just means that we're going to take a couple of equations and we're going to graph them on the same, we're going to put them on the same graph. And we're going to see how they relate to one another on that graph. Okay? For instance, a system of equations can have 0, 1, or infinite solutions. And what that means is the solutions that a system of equations share is their points of contact. And so if two lines never cross each other, never touch each other, what kind of lines do we call those, by the way? Parallel lines never cross each other. So if you have two parallel lines, such as this red one and the green one here, they're parallel, they never touch each other, so they have 0 solutions because they have 0 points of contact. Okay? Some lines cross each other once, such as the blue one and the green one here. That's the only time they would ever touch each other, right? Okay? And so they have 1 solution. And we'll talk about what that means later. And then a system of equations, it's possible for them to have infinite solutions. Can you think of what case that might be, Abe?
They both have the same points.
They have the same points. What does that mean?
They're on top of each other.
They're on top of each other. It's the same line. You can have two equations that look different, but when it comes right down to it, when you solve it for y or you get y by itself, they're going to look exactly the same. It's going to be the same equation, so when you graph them, they're going to take the same spot on the coordinate plane. Okay, so we have 3 different types of scenarios then. We have parallel lines that have 0 solutions, we have intersecting lines that have 1 solution, and we have identical lines which have infinite solutions. Okay, does that make sense? All right, we're going to look at just a number of examples now. We're going to graph some lines. We're going to see what type of solution they have. If it has 1 solution, we're going to name that ordered pair because that's a big deal for this lesson. So let's see what happens here. So we're going to graph the system of equations and we're going to determine its solution. Okay, so I have a blue equation here. I color-coded some of them here on my so we can see them a little better. Y equals negative 2x plus 3. So let's graph it. What do we do?
Down, negative 2.
Y-intercept is 3, and slope is negative 2, so down 2, right 1. Or we could go up 2, left 1. Okay, so if we graph that line, right there, and then we can graph the red one, y equals x minus 3. So we go start at negative 3, the slope is up 1 over 1, okay, so we can go there. Alright, so first of all, how many solutions do we have? Obviously there's 1 solution. And if my lines were perfect, which my blue line I think is off a little bit maybe, but what is the point of contact right here?
2, -1.
It's over 1, 2, down -1. That's the ordered pair. So the solution to this system of equations would be 2, -1. That's the solution. Okay? Does that make sense?
Yeah.
All right. Let's just work through some of these and see what we see here. All right, so we've got another system here. Aiden?
Oh, right, these are
how do you know these are gonna be parallel?
Because the y-intercept is the only difference.
Okay, the y-intercepts are different, but what specifically is the same? The
So
slope. That's a great observation. Okay, the slopes are the same number, which means they have to be parallel. And if they're parallel, then they are going to have how many solutions?
0.
0 solutions. Okay, let's graph them and confirm it. 2x plus 3, so up 3 right there. Up 2 over 1. Okay, and then we've got 2x minus 3, so minus 3 right here. Go down to left 1. And if I drew them properly, they're parallel, and so they have 0 solutions, okay? So you would say, and it's not a no solution graph like we're used to with some of our equations that don't work. It's actually 0 solutions, okay? Does that make sense? There's a difference between no solution and 0 solutions. All right, graph each system of equations. Yeah, graph each system and determine the number of solutions that it has. If it has one solution, name it. Okay, so y equals 3x plus 10. So this is a different graph here. 3x plus 10 is right here. Down 3, which way?
Right. Or left.
Left 1, thank you. It's got to be a positive slope. Down 3, boy, it's about too small for me to see from back here. Should be right there. That should be good to get a line. So it looks like that. And then x minus 2, so 2. And then I think I'm on the right track there. Oh, good grief. Hate it when that happens. All right, so what is my solution?
One.
There is one solution, and then name that solution, which means give the ordered pair. I sure can't count it from back here.
5, 7.
-5, -7.
Yeah.
Does that work? Okay. All right. All right, let's try these. These are, what's different about these?
You have to flip them.
They're not in a form that is graphed easily at this point. So we've got a couple choices how we can graph them. The easiest thing probably is to solve for y, right? Get its slope intercept. So 2 minus 2x. So negative y equals negative 2x minus 1. Everything by -1, so it's y equals 2x plus 1. Right? So plus 1, up 2 over 1, up 2 over 1. Should have gone back to the smaller graph. This one's hard to see. All right, now, same thing here. Let's set this one equal to y. So we've got subtract 4x. So negative 2y equals negative 4x plus 6. Everything gets divided by negative 2. So y is 2x minus 3. 1, 2, 3. So down to left 1.
0 solutions.
zero solutions. Did you know that before we graphed it?
No.
We could've.
Not sure my lines are perfect there, but it's good enough. Once we had this one here, we could look and see that they have the same slope, right? Even if we hadn't graphed them yet. I still want you to graph them. We still need to make it obvious on the graph, but yes, Aiden.
Could we still tell if they have common factors?
Sometime, yeah, I mean, you'll get better at seeing them ahead of time as you do this more and more and see the way the slopes work out. You'll get to where you can recognize probably even in different forms if they're parallel or not. And then we're going to do some other work. I mean, as we move on from here, we're going to do work with systems of equations besides just graphing them like this. And we'll see some other things as well. Okay, so that's a good question, but we're moving that direction. All right. Blue one is already in slope intercept. Let's graph it. So y equals negative 2x minus 3. So down 3, 1, 2, 3. Negative 2, slope would be down 2, right 1. Part of what I like about this is just all the practice we get graphing equations that you guys should be pretty good at already, but never hurts to get the review on it. And then let's solve this one for y. So subtract 6x. 3y equals negative 6x plus 9. Divide by 3. So y equals negative 2x plus 3.
They're infinite.
Infinite?
Zero. Yeah. No.
Okay.
because It's different slope. I mean, it's different intercept.
Different intercept. It's got the same slope, but a different intercept.
Yeah.
Okay, so 1, 2, this one would actually be positive 3 intercept,
Parallel.
and then it's got the same slope, so it is parallel. So it's infinite solutions. Or no, it's
No.
zero solutions. Zero solutions. All right. So this one goes like so. All right, so 0 solutions for this graph. All right. Last one, and then we've got one more problem after this, but last one like this. So x minus y equals 2. So subtract x. Negative y equals negative x plus 2. Multiply by negative 1, so it's y equals x minus 2. X minus 2, so negative 2, and then a slope is 1. Should be right there. All right. Let's set this one to y, so subtract 3x. 2y equals negative 3x plus 9. Divide by 2, this is going to be a weird one. Negative, so it's y equals negative 3 halves x plus 4.5. Yikes. I'm going to have to closer. You can see it back there. So x is up, or the y-intercept is up 4.5. And then you'd go up 3, 1, 2, 3, left. 1, 2, 3, left. 2, 1, 2, 3. Right about there. Sometimes It's got one solution. Sometimes that solution is kind of hard to see. So if we go down 1, 2, 3, over 1, 2, I went right through it there. So this is a weird ordered pair right here, isn't it? So we just have to do the best we can. It's gonna be over, say, over 2.5,
2.5,
and it's up about 0.5. Sure, I mean, we can do the best we can with it. Sometimes they're just hard, not every line crosses in exactly the right spot for us to make it an easy ordered pair. And that's okay. Just do the best you can with it. Tomorrow, or as we move on, we'll get to where we nail that spot down exactly. We'll solve the system of equations so that we can know exactly where that spot's at, even if it's a weird decimal or fraction. All right, then we might have some word problems. And here's what we'll do. Will and Jen are competing to see who can sell the most tickets for the winter dance. On Monday, Will sold 22 tickets and then sold 30 per day. Jen sold 53 on Monday and then sold 20 a day after that. So we need to solve some equations, or write some equations. So let's write Will's first, and Will will be red. Okay, so this will be Will's equation. So how are we going to set up Will's equation here? 22 at first and then 30 per day.
Y equals 30x plus 22.
Yeah.
30x plus 22. I like that. So his total number of tickets would be the 22 that he sold the first day plus 30 a day after that, right? Okay. And then we'll write Jen's equation. So what is Jen's equation going to look like?
Y equals 3x plus 53.
So she sold more the first day, but sold fewer per day after that. Now we need to graph the equations. And I just realized I didn't give you guys a graph to graph these on, did I? I'm gonna have to go to a different, this is gonna be weird. Copy. There we go. Oops, I missed one. All right. Sorry, should have had this on there. I forgot to put it on the sheet though. Actually, you know what? Let's get rid of this. This graph is not gonna work. Let's get rid of it. Let's use this graph. I like this one better. All right. So we need to go up by tens on this one. This will be easy on the x-axis because it's just going to be easy. 20, 10, 20, 30, 40. You get the message. I'm running out of room. Can we go up by tens here as well? Start out at 53. That's not going to give us much room. So let's go up by 20s. 20, 40, 60, 80. All right, so in blue, we've got Jen's equation. So up 53, up 20, 40, 53 is about right here. And then she goes up 20 per day after that. So up, oh wait, these are days, not tens. Sorry, that should just be numbered by ones. Number of days, 2, 3, 4. So she goes up 20 every day, which would be up 20 over 1, up 20 over 1. So her graph looks like that. And then old Will starts out at 22. So down here, he starts off in the way behind, but he goes up 30 a day. So up 20, 30 is going to be about right there. And then 30 is going to be about right there. So his graph, this is going to be hard to see. How many days does it take for Will to catch up with Jen?
4.
This is 1 day, 2nd day.
Third day.
It's just after, it doesn't quite happen the 3rd day, but by the 4th day, he's way ahead of her. So sometime in between that 3rd day, around that 3rd day is when he catches, I think in the book it said the answer was like 3.1, which is kind of weird because they weren't checking 3.1 days, but we got pretty close. So the solution would be that 3.1 and about, if we're up by 80, that would be 100, at about 110 tickets is where he caught up with her, right? All right, that's the kind of thing we're gonna do. Don't freak out about these word problems. We'll get through them. Oops. Your assignment is a worksheet that I've got printed out. I forgot to write it on there. 6-1 practice worksheet. Guess I printed my slides before I was ready.